Hey, so welcome back, and this is another daily code problem. So today it's called swapping nodes in a linked list. And so it's a medium level problem where you're given a linked list here along with an integer k. And all that you want to do is you want to swap the node that is like the kth node from the start, which in this case is this one, because the number is 2 here, and well, this is the first node and this is the second node. And then you want to switch places with the node that is the k from the end. And so this is like the first last node is how I thought of it, and then this is the second last, so you'd swap 4 with 2 in this case. So then it becomes 4 and then 2. Okay, so to do this, the first thing is you want to check kind of the base case where, okay, what if there's nothing? In that case, we just want to return null. So if you get a null list, you can't swap anything anyways, so you might as well just return it. So if there's no head, then let's just return the head, or I guess really in that case you can just return none. Otherwise, you want to keep processing it. And so typically for these type questions where you need to know like the given index of the node, you want to first find out the length. And so that way you can find out, okay, what is the kth? You can easily find out like and count forwards, you know, say you're given k equals 2, you just say, okay, 1, move over 1, and then 2. So you just travel it, you know, for I in the range of 1 to 2, and you just hop twice. But when you want something like kth node from the end, you want to get the length, which is in this case 5. So this has a length of 5. And so to get the kth node from the end, which is in this case this one, you would just do 5 minus 2, which is then 3, which would then point to this one because this is 1, 2, 3. But then because we want actually this node here, you just do 5 minus 2 plus 1. Or really 5 minus k. That's 5 minus k plus 1. Okay? And so that's basically it. So we want to travel forward k times to get the kth node from the beginning. And then we also want to grab the length of the linked list in order to travel 5 or like the length minus k plus 1 times to get the kth node from the end here. Okay, so that doesn't make sense. It might make a little more sense once we write out the code. So at the end of this, we're going to want to return the head of the linked list again, but we'll have modified that linked list. And so the first thing that we're going to want to do is let's find out the length of this linked list. And so we just want to say, okay, let's have some node, and we're initially going to set it to the head, and we want to keep iterating and moving down this list once we reach the end. And so we just say while we have a node here, okay, while it's not none or not null. And so we just keep saying, okay, node is equal to the next node. And that's just how we move down the list. But while this is going, we want to be incrementing the length starting at 0. So with each iteration, let's just add 1 to the length. And so that's basically how we get the length of the linked list. But now what we can do at the same time is just grab the kth node from the beginning as well. And we just want to say, okay, once the length is equal to k, that's the kth node from the beginning. And so we can just set that here. So we'll say like a start node, I'll call it, and that represents the kth node from the beginning. And that is initially going to be equal to null here. And so we'll just set that here where, okay, if the length is equal to k, then let's just set that start node equal to the current node. Great, and so that's how we get our kth node from the beginning. And so now we still want to find the other node, which is the kth node from the end. So let's find the kth node from the end. And so to do this, all that we want to do is say, okay, let's keep iterating down this list, starting from the head again. So we want to reset our node at the head. And we just say, okay, let's iterate through this list in the range of 1 to k, or really the length, minus k plus 1. And so I will just say, okay, between the range of 1 to, in this case, 4, let's just keep iterating through this list. And all that we have to do is, oh, I didn't fill this out correctly, 4 underscore in the range of that. And so with each iteration, we just want to move our node to the next node. Great, so at the very end of this, we're finally going to have the end node. And so actually we can just set this equal to end node and do the same thing here. Okay, so now we have both the starting node and the ending node here. And so all that is left is we just want to say, okay, let's swap them. And to do this, you don't even actually need like a deep clone of it. You don't have to switch the pointers around. All that we have to do is swap the values. And so we can just use a temporary variable, which will grab the starting node value. And then we can just update that start node value to the end node's value. And then basically repeat that process for the end node here to be equal to what we stored in that temporary variable. Great, and so this is just swapping the two node values. So let's go ahead and run this. Oh, just forgot a colon. Oh, I think there's an infinite loop here. So while node, I believe we're doing node.next. What's going on here? Recursion. Oh, so we just want to set the value here. Looks good. Yeah, so all that was happening is this ended up having a cycle in it. So it was basically when we were evaluating this with different test cases, and it would have iterated through the linked list. The linked list that we were returning had a cycle in it. So that's where the recursion max depth error was coming from. Yeah, so that looks good. Let's try submitting it. And success. So basically this runs in O of n time, or really like O of 2 times n, but it rounds down to O of n, where n is the length of the linked list. And that's just because we iterate through the linked list entirely, at most twice. And then for space complexity, well, this is just O of 1, or constant space, because we don't use any extra data structures other than what's given to us and variables, which doesn't really count, so it's O of 1 space. But yeah, I hope that helped, and good luck with the rest of your algorithms. Thanks for watching.